Hi, my name is Daniel Moth, and today I will show you a very quick demo of one of our C++ AMP samples that we call nBody. You can get the Visual Studio project and all the code for the sample by visiting our blog, and I will share a link to that at the end of this short video. So in this app, what you can do is you can change the number of bodies. So currently I'm at 4,000. And you can also switch between different implementations of how we perform the calculation of simulating the gravitational interaction between that number of bodies. So currently we're using a single core implementation. So we're simulating how these red dots basically interact with each other, and that's an expensive operation. So you can see that right now with 4,000 bodies, I'm getting 18 frames per second, and I'm getting just over 6 gigaflops. If I was to go and throw more bodies at this, so if I just double the number of bodies that we have, you'll see that the gigaflops actually doesn't go up. That means that we have maxed out the compute capability that we can get out of this single core, out of this hardware. And of course, because we have done that, when we threw more bodies, the frames per second went down because it's taking longer to go and render the frames after it performs a calculation of where each body should be in that next frame. So what I can do is I can also go and use a multi-core implementation. So we coded up a different code path using PPL, the parallel patterns library. And if I choose that, you'll see that now the gigaflops and indeed the frames per second go up. So we get a nice increase in the gigaflops that we're getting out of all these cores, and the frames per second has also jumped up compared to the previous state. And if we go and open the task manager, we'll see here that we're using 100% of the 4 logical cores that I have, and the graph demonstrates that. If I was to switch to the single core version again, not only things slow down, but you can see now the utilization has significantly dropped. And the real number here is just under 15, because a lot of the CPU utilization is taken up by the recording software that I'm using to produce this video for you. And actually, that's a good point. I want my CPU to be used by other tasks, not by my truly compute-intensive algorithms such as the one that I'm running here. And that's where using C++ AMP comes in, and you see the CPU utilization drop into just what the recording software uses, while the gigaflops have jumped up considerably. It's now 260, so we're way over 10 times faster than the multi-core implementation with the same number of bodies. And of course, I can go and throw even more bodies at it. So if I just go and double again, so we can go up to 20,000, you'll see that we're getting close to 300 gigaflops here, still with a respectable 31 frames per second. So now we're not using our CPU for this computation. We're using C++ AMP and the GPU, specifically the AMD GPU that is driving my screen. Now, this is using C++ AMP's simple model, and we're getting this tremendous speed up. Those of you familiar with the C++ AMP programming model will know that we have a tiled model as well, which allows you to get even more performance out of the GPU. So if we go and switch to our tiled model, you'll see the gigaflops jumping yet again. So it's now over 3 times, it's about 3 times faster than the simple model, which itself was over 10 times faster than the multi-core solution. So we're talking about game-changing performance improvements that you can get by using C++ AMP and the GPU for your compute-intensive data parallel algorithms. And of course, I can go and throw even more bodies at this. The gigaflops keep going up, as do the frames per second. So we're at 49 frames per second and close to a teraflop over here. Now, what I also have on this system is another GPU, and this GPU is from NVIDIA, so it's from a different vendor. And of course, with C++ AMP, you can use all the different GPUs from multiple vendors. And I can go now and switch to multi-device on GPU, so use even more devices. I can throw even more bodies. Let's take it all the way up to, I don't know, 67,000 bodies. We can go even more. And we do that, you can see that we're getting out of these 2 cards over 1.5 teraflops through this nBody simulation app. And I can tell you, and there's video proof of that. Recently at a conference, I was showing the 2 latest GPU cards from these vendors, where I was seeing 3 teraflops from 2 GPUs in this exact same app. And that goes to show that you just code your solution once with C++ AMP, and then as new hardware comes out from new vendors and more powerful hardware, your solutions just scale and become faster. You don't have to change anything in your code for that to happen. So on that note, you're probably wondering, where can you get this code? So you can see how we wrote this, and you can indeed download this Visual Studio project from our blog. So if you go to our blog, which is at blogs.msdn.com/native concurrency, and then on the right, you can go and find C++ AMP samples, and when you click on that, it'll take you to this blog post. And this blog post is basically a table of contents. It links to a whole bunch of other samples that we have, and we'll keep adding to this list. So go to this URL, and in fact the first sample we ever shared was the N-body simulation. So you can go and click on that and read about the sample app, and from there you can download a zip file with a Visual Studio project, and you can study the code and learn from it and run it on your own hardware. So thank you very much for watching this video, and always your questions are welcome for C++ AMP in our MSDN forum. Thanks.